I would like to give you the stage, so have fun.
Okay, thank you very much, Walter. It's a pleasure to be invited to give a talk here. And the title of my talk is going to be Why Intelligent Systems Need Organizational Intelligence. And a couple of days ago, I went onto LinkedIn and I actually saw this on the LinkedIn message. So for those of you who are expecting me to talk about the role of elevators, I think this is actually the talk from someone else before me.
Yes, that's true, Paul. That's
Indeed, I was thinking, what am I going to talk about elevators? But I think this is also quite interesting because some of us maybe have the experience of taking a smart elevator. And the point about smart elevators is that we do not press necessarily the floor numbers in the lift, but we actually press it outside the lift. And that can actually help us optimize maybe the human movements. And particularly with Corona and safe distancing, maybe that can be built into the smart systems. But really the purpose of my talk is to not really focus on the technology, but also on the user's experience. Because of course, if there is a change in the system, then it needs a bit of getting used to. Otherwise, we are very disoriented. So indeed, that's really what I want to talk to you about today. But first of all, maybe a brief introduction. So I'm a professor of design and construction management in the Faculty of Architecture in TU Delft. And I've always been very interested in looking at the production of the built environment, not just as a technical process, but also as a social process. So I put in bold, the key focus of a lot of my research tends to be around how people cope with change. So that change may be social, organizational, or technological change. So I'm going to maybe in this talk reflect on a couple of recent and ongoing projects, and I've just listed a couple there, which I will elaborate as I go along. Some of these are done by my team, but also by colleagues within the group. So the scope of my talk is, of course, now we are always talking about disruptive innovation, the fourth industrial revolution, and maybe I will give a brief background on that. And then also the question of technology. Particularly, I think technology is not really the answer to our problems, but it raises new questions. And I maybe want to get us to think about that through the examples of my recent projects. And at the end, maybe some lessons learned if we can get there. So by now, I think a lot of you are very familiar, perhaps with this World Economic Forum image on the future of construction. This was published sometime in 2018. And what you see here is actually a whole bunch of different technologies that I think are becoming more popular nowadays. Particularly with Corona, I think we are constantly now thinking about how can we have autonomous systems, robotics, so that maybe we reduce the need for human labor. But if you look at this graphic, the technologies are not necessarily new, but it's actually a combination of these technologies and the way we use these that I think are really opening up a lot of new opportunities. And indeed, I think for a long time, we've always been imagining what happens when we have a very smart society. Can we have an automated, robotic, and smart city? And this is just an image taken from a journal article in automation and construction. And you can see that everything is connected. So nowadays we have these Internet of Things, the cyber-physical networks. These are kind of labels that try to show that we are actually connecting not just humans and humans, and not just humans and machines, but also machines and machines together. And there are a couple of developments, I think, in industry. I've taken this image from MX3D. So it's a 3D printed bridge across a canal in Amsterdam. And of course, now in the experimental mode, they are also trying to build in sensors within this 3D bridge to try to understand the structural conditions. So using sensors for condition monitoring, I think that's becoming more widespread. This is an image taken from Sidewalk Labs, part of Alphabet Inc., Google. And this was a prototype of a building raincoat. So can we build sensors so that, when it rains, we can wrap around the building a raincoat so that the building is kept dry. And what you see also here are the pavement slabs that can also heat up so that they can help us melt the snow when it's during the winter time. These are some sort of technological solutions that Sidewalk Labs proposed as part of their Toronto master plan. And it was really quite impressive. But in the end, I think they didn't get the bid because the panel thought, well, actually, this is technology for technology's sake. And they were quite concerned as to what Google was going to do, perhaps with the data that they were going to harvest. So again, I think this raises the question of, I think the technology is already there that can help us do a lot of things. But clearly, I think that there are a lot of social impediments that are kind of stopping us from making that progress. And I'd like to maybe delve deeper into that in my talk. This is another example. And I think maybe what I want to really get us to think about is that these are not new challenges. I think for a very long time, we've been talking about integration across the value chain. So this is an example of Catera, where they have this end-to-end integration where they get the product manufacturers together with the fabricators and also the assembly people. Can we kind of really integrate across the different parties in that chain? So just maybe some text here, a definition of the fourth industrial revolution. As I've mentioned in the beginning, these are not new technologies, but maybe new combinations of technologies that allow us to achieve that integration. And I've highlighted a couple of words here in the definition, which is also about the creation of a digital value chain so that we can better communicate across parties and we can plan and also deliver improvements to products. But of course, we also know that the industry is often very slow to react to these innovations. I particularly like this image. I think before the pandemic, we never thought that we would actually scale up the digital engagement to this extent. And of course, now I'm talking to you, in my study, whereas in the past, I think we would be interacting with one another at the conference. So indeed, I think there are these disrupting forces. McKinsey Institute, of course, wrote a report last year called The Next Normal. And within that, the people that they poll actually think that we are going to shift towards these digital trends in a greater scale within the next 5 years, in part because of the pandemic. And part of this transformation is that it's not just digital technologies, but how do we connect that up with the industrialized process in producing the built environment? And of course, I think with any change, there's always going to be a kind of challenge, a tension between the new entrants, the disruptors, and also the established parties. And I think this is where really interesting questions can be addressed. Again, I think whilst we have a lot of those promises that technology is going to help us solve a lot of optimization problems, we are still not there yet. In this particular graphic taken from PricewaterhouseCoopers, we constantly see that construction is rather kind of slow in terms of adopting new technologies. Here, I think the people polled think that in construction, around 40% of our jobs may be automated and robots replacing us, which is not quite the kind of full scale that we often think about. Again, in the World Economic Forum, when the CEOs were polled, if you look at this, the key challenges, they are not really about the technologies themselves, but about people. It's about social aspects. It's about attracting new talent. It's about upskilling the existing workforce. And it's also, again, that word integrate. How do we better integrate and collaborate across the multiple parties in the value chain? And I think that that is really a challenge we need to really examine in more detail. So I want to, before I go into the examples, I want to share with you this particular graphic, which I find really interesting. This is quite old now, 2016, and it's done by an economist. He used to be in the Netherlands, but I think now he's in Manchester. And what he and his research team did was to analyze the productivity improvements across different sectors. And the focus here I want you to pay attention to are the dark blue bars, because these bars represent the most intensive ICT using sectors. And what he found was really interesting, that actually over time, the sectors that actually have the least productivity gains are in those sectors that are very intensive in ICT use. That's information and communication technologies. And this really baffled the researchers because, the conventional wisdom tells us that actually if you invest in ICT, then our productivity will shoot up. So when they got these results, and this was not just in one country, they did a comparison between the US, the UK, and Germany. They actually found that consistently the productivity levels decline. And so, baffled by this paradox, they wondered, why is this the case? And one of the explanations they came up with is that perhaps we are using the new technologies using the old logics. So the classic example that we often share is when we move from typewriters to computers, well, we still use computers to type. So indeed, we may improve our productivity up to a point, but actually at the end, we also reach the maximum limit possible. And so I really want to get us to think about these new technologies, and are there possibilities of using them in different ways? Maybe we need to question the logics of our use. And I really like this next slide I've taken from, I think, one of the companies, Intelsys, who actually depicted the disconnected software silos. And again, on the right-hand side, you will see the various operations from manufacturing to supply to the demand side, and the whole range of different IT tools, software tools that are available. And maybe we are just reproducing the silo mentality also in the software use. And maybe I think we need a lot more integration across the board. Otherwise, we'll just be not integrating the value chain, whether it's software or hardware. So I want to share with you now 3 projects and some of the lessons learned there. And the first project I want to share with you is a project I did with a contractor in the UK, who was very interested in around 2013 of trying to see how they can shift their business model. At that time, they were trying to look for new opportunities, and those new opportunities were around the mechanical and electrical processes. And the main change that they wanted was to think about the energy plant rooms. In the past, they would sell you these energy rooms, plant rooms, as a product. And they thought, well, instead of selling you as a product, can I actually sell you predictive performance? So this was really the start of the journey. They wanted to figure out what do they need to do to get there. So this is, I think, in the academic world, we call this a service model. So instead of selling you a product, I sell you a service contract, but in return, I guarantee you predictive performance. Now, we then use this particular framework. One thing that I like about this framework, which is called activity theory, is that usually in an engineering context, we think of inputs and outputs. But in this particular framework, we also realize that there are people involved in turning the inputs into outputs. So these could be the division of labor, the community of practice. It could be the rules of engagement. Sometimes regulations either stop us or stimulate us to do things. And of course, there are technological tools involved as well. So I'm going to take you through a journey. This was the journey that the company took to move from selling modular plant rooms as a product to selling predictive performance. So the first thing they said was, if I'm going to move to predictive performance, then I need to understand the performance of the equipment. And therefore, the first thing that I need is detailed technical information. In order to kind of move to this new business model, I need to know when my equipment is likely to break down. Because if I can predict that, then I can also start to cost the service contract. Okay, so this sounds really easy, right? So we need detailed technical information. But there, they actually meet a contradiction because the equipment suppliers at that time did not produce this detailed technical information for two reasons. One, the existing business model for these equipment suppliers was, I'll sell you the product, give you a 2-year warranty period, and I hope that in future you will buy new products from me. So there was no incentive for them to really figure out when the equipment was going to fail. Or even if they knew when the equipment was going to fail, they also never shared that information with their consumers because, this is part of their kind of trade secrets. So in the end, what happened was they really needed to build trust. The contractor needed to build trust with the equipment suppliers in order to develop that detailed technical information. And as a result, they actually shrunk the number of equipment suppliers that they collaborate with. But this then created another contradiction because their existing procurement rules actually only allowed them to go for lowest cost rather than highest value. So they really had to work around those procurement rules. And as a result, I think the company, the contractor, actually bought over one of the equipment suppliers. So this was also how they got around the procurement rules. Okay. The other thing that they needed to figure out is, apart from the technical data, how would they know that the equipment was actually in good condition? So somebody said, well, actually, let's maybe put in more sensors, advanced sensing capabilities, which is fine. But then they realized that this generated the need to hire data analysts, because actually, before that, they didn't have all this data to analyze. And now they have all this data, but they don't know what to do with it. So I think every time when we introduce some technological change, there's always a kind of knock-on effect on organizational practices. Now, in the end, what was very interesting is we did a case study, and this case study was relating to a hospital project. And when we got the intelligence and we knew, for instance, that this was an optimal way forward, there was also another contradiction, because maybe the optimal, one of the optimal solutions was knowing when to shut down equipment so that we can prolong the useful life of the equipment. But of course, in hospital environments, these are critical spaces. And so shutting down equipment was also quite a contentious issue. And so what we saw was the technology was not really the answer, but actually it raised a lot of questions, so that different parties can come along and negotiate their requirements. And so one of our conclusions is that these systems integrators have to really reflect on these changes to different parts of the system so that they can constantly start thinking and rethinking their value propositions. And therefore, I think change sometimes takes longer than we would have liked. Okay. The second example I want to share with you is done by my colleague and others, Ruben Freihoff and TNO and several other institutions. And this was a project called Crosstrain Control Center. And the vision here was, instead of sending building logistics from the supplier to the site, and that creates a lot of multiple trips, the question was, how can we bundle together logistics so that we can find the most optimal, low carbon, less traffic congestion route, more direct route, and share that between different sites? Sounds really simple, and indeed we have the technologies to help us do that. mapping technologies, RFID technologies, uh, communication technologies, etc. But the lessons learned from this particular project revealed 4 issues. So the first thing is that we need more insights. So a lot of these data-driven digital technologies always sell us the promises of giving us more insights. But this is where there is a bottleneck, because those insights have to come from different sectors: transportation, logistics, building sites, projects, contractors, subcontractors, etc. And so we need to pull all this information together and also make this information easy to use. And I think that that's a contradiction. It's often quite difficult to actually understand what information can we pull together from different sectors and how to make them user friendly. And I think we are still in the kind of evaluating and learning process. I've put some references here, which I'm sure Walter can share with you afterwards. A final example I want to share with you is a project called VR Renovate, done by my colleague Clarina van Oel at TU Delft. And in VR Renovate, the question that we are asking is, how can we use virtual reality technologies to better communicate renovation to the social housing tenants? As we know, when we renovate buildings, it can cause a lot of disruption, and tenants are often very resistant to that. So how can we actually use virtual reality to help in that communication? We've just started this process, and there's a couple of PhDs and postdocs. And one of the PhDs is really using this very interesting technology, combining virtual reality to represent the physical environment, but also eye tracking technology, so that we can follow the user's eye movements to figure out what are they focusing on. Because we think that when they focus on particular objects in the VR module, they may be actually asking questions in their head or trying to make sense of what's going on. So we're combining not just technology solutions, but also an understanding of the users and also their psychology, their emotions, their interactions with one another, to try to understand how can we improve the communication process that hopefully also improves the delivery process by the contractors. So I think there's a lot of coordination work that we need to understand in this piece. So I'm coming on to the end of my talk now. In my group, Design and Construction Management in TU Delft, we are very interested in working with industry to try to figure out how we can design process innovations to future-proof the built environment. And I think academics are very good at giving you strong evidence that we also want to work with industry to engage with you and to maybe come up with some interesting solutions. But ultimately, as a researcher, what we tend to do is we collect lots of data. We use the data to try to explain what is going on, and maybe to also visualize what could happen in the future in order to challenge the present. But there are 4 areas that I really want you to think about and that we are very interested in our group to challenge. And being in TU Delft, of course, the first thing is we are interested in new technologies. But with these new technologies, we are also asking questions around the institutional rules of engagement. Are the regulations that we have right now fit for purpose? How should they change to engage with the digital transformation? What are the people's reactions to these changes? We often think that they resist change, but in our view, resistance to change is quite natural. It's part of the learning process. So how can people develop new learning, new practices to deal with this technological change? And finally, I think we need to also think about our systems delivery, our value chain. How can we integrate across the different suppliers and also the different customers and end users? So I think we need to do a lot of stepping out. I've just started over a year ago a new research project called Stepping Out. And the idea, of course, whether we use a digital model or, as this graphic shows, a physical model, we need to talk to one another. we need to step outside of our knowledge comfort zone to try to understand and to try to produce these creative solutions. But of course, stepping out is very difficult. There are three barriers I think that we need to address, and I hope over the next few years, stepping out projects will address these. The first is language. Sometimes we use terminology. Maybe we use the same terminology, but we mean different things, or we use different terminology to mean the same things. So I think we need to understand the language across multiple agents. The second barrier is the interpretive. In other words, we are all trained in a specialism, whether engineering or architecture or etc. And each of our training actually gives us a way to interpret the world. And maybe we need to actually have more cross-disciplinary education. And finally, we also have vested interest. We represent and belong to organizations, and we also have our vested interests to defend. So remember my example of the equipment suppliers versus the contractors, and why maybe we don't have the technical information that we need to make the change happen. So my last slide now, I think there are three key takeaways I think I want to share with you. The first, I think, is that technology is the question. It raises new questions rather than the answer to give us the answer. And I think we also need to think about the users, how they use the technologies, their journeys, their experiences. And we need to understand and redesign our organizational logics and practices to really exploit the full potential of these technologies. And finally, maybe an invitation to you. I think this is where academia and industry can work together, because we also need to step outside of our comfort zone. After all, a lot of the research that we do will also feed into the education of the next generation of practitioners. So hopefully we can step outside and then work with one another to actually develop more better organizational intelligence for intelligent systems. Thank you very much.
Wow, thank you very much, Paul. That was amazing. I have a question for you, if that's okay.
Yep.
You work, of course, with a lot of students, and those students, they are probably very much involved in that new technology, in that new way of working, in that future of construction. How do they see the collaboration with the companies that are already working in that construction, and how do they really want to work in those companies, or how do they see that?
Yeah, so in fact, our students always inspire me because they know the new technologies that are coming forward. Nowadays, also, we have a lot of gaming technology. So it's not just visual representations, but gaming. But what I think they lack is an understanding of how the production process. So I think that you need to have some understanding of the production and then some understanding of the new technologies. And the way we do that is twofold. In a lot of our courses, we also get guest speakers from industry so that they can also have that interaction. But we also have graduation thesis where the students often do an internship in a company. And my experience has always been, in the Netherlands at least, that the companies are always very open because they also want new ideas. They know that things do not work 100%. So they're always also fishing for new ideas. And I think they're also very willing to invest in students. So I think that conversation is a very nice conversation to start with through the graduation projects.
Yeah, cool. And I really liked your insights on the level of ICT that you put into a company, and if it is productive or not productive. That was a great insight. What technology do you think will have the biggest impact in, well, the next 2-3 years on construction? Is it robotics? Is it what is it? Is it VR? What do you think? Is it data?
So I think that definitely data. And I think something that at the moment people are talking about, but maybe don't really know very much about, is digital twins. And I think that at this moment, a lot of people think digital twins is just producing more models. And I think that that's not really the right way to go forward, because once you produce a model, you then have to spend a lot of energy and resources to update the model. And then we forget actually we need to use the model to make decisions. So I think that moving forward, data is going to be important, but I think it's not so much big data, but valuable data. So maybe we need less data, we need less accurate models, not more accurate models,
Yeah.
but actually to use the models to really make decisions across different parties. And I think that's where we're going to go forward in the future.
Well, cool. Well, thank you very much, Paul. I hope I can visit you really soon when this pandemic is really over. We're going the right direction in the Netherlands. So I wish you a good sunny day and hope to see you soon.
Okay, thank you, Walter.
Thank
Yeah.
you very much.